In a previous video, we have practiced using direct substitution to find limits. We took whatever x was approaching, plugged it in, and found our limit. But sometimes that's a problem. And it says, why can't we use direct substitution on this problem? Well, if I took 0, plugged it in everywhere, I'd have 0 as my denominator. And that's the problem. So let's write that. The denominator would equal 0, and that's a problem. What can we do about it? Well, up top I'm noticing a common factor, so let's say factor. So let's slide over, let's look at this one over here. Same problem. Got to find the limit as x approaches 0 of this. So if I plug it in, it'd be 0. That's not good for my denominator. So let's rewrite it like this. Let's write limit as x approaches 0, and then let's factor that x out up top. So if I factor an x out, greatest common factor, I'd be left with x squared minus 7x plus 12 over x. And then I can zap these x's right here. Pew, pew. And I'm left with the limit as x approaches 0 of x squared minus 7x plus 12. And now, if I take this 0 and plug it in, I can do that. I can get an answer. There's no crazy, divide by 0 error. So let's take that and plug it in. 0 squared minus 7 times 0 plus 12. 0 minus 0 is 12. And so as we move forward, we're going to be seeing problems where, for whatever reason, when I try to directly substitute it in, it doesn't work. Like, maybe there's a 0 in the denominator. For whatever reason, it's not going to work. And we have to do some sort of algebra to fix that. So let's look at another one. These first, just this week's lessons, we're just going to be factoring, and moving on, we'll do some other stuff with radicals, but for now, we're just going to be factoring. Very similar to the first problem. So let's write, I'm noticing the common factor up top, x up top. If I factor an x out, I'll be left with x squared plus 2x. Ooh, that was a minus 15. Max, don't write in pen. Over x. And then I can zap the x's. Pew, pew. And I'm left with limit as x approaches 0 of x squared plus 2x minus 15. And I can take that 0 now and plug it in. That is negative 15. All right, let's slide it over here. And man, which one of these do I want to do? The first one's kind of easy. I kind of want you to have to do this. Some of you'd have to use the box. Oh man. I guess I'm gonna do this one to be nice. What a nice guy. Limit as x approaches negative 4. So before we really start, if I were to take negative 4 and plug it in, that would be 16 plus 4 would be 20, minus 20 would be 0. That's a problem. My denominator can't equal 0, so we have to factor. Let's factor up top. If you need to use the box, you can use the box. If you can it really helps that 2 is prime. So I need two numbers that will multiply to give me negative 4. They gotta add to give me, so I think positive 4 would go right there. That'd make 8x, and then minus 1 or minus 1 right there. Yeah, I think that works. On the bottom, I need two numbers that will add together to give me negative 1 and multiply to give me negative 20. That would be what, negative 5 and positive 4. So that works. Okay, so I'm noticing I can pew, pew, right there. And if I take -4 and plug it in, I won't get 0 on the denominator, so that's good. So let's take it and plug it in. I got 2 times -4 minus 1 over -4 minus 5. And that is what? -8 minus, was that -9 over -9? Is the limit 1? Another word right here. Removable discontinuity. Anyways. 1, final answer. Go Dogs. All right, let's look down here. Yes, a little soap. Yes, all you people in 7th period. Especially people sit on the front row closer to the door. Not you, Jake Varner. Person who sits next to you. I'm thinking about, I think the 2 is what we were worried about. It's like x cubed minus 8, and someone was really worried about a 2. Let's do this one. I think it's going to be a weird one and not exist, but I don't know. Let's try it anyways. I've got limit as x approaches 2. Once again, if I plugged in 2, that'd be 4 plus 4 is 8, minus 8 would be 0. Up top, going to use a little soap to factor that sum of cubes there. So I could rewrite this. I'm going to slide that up. I could rewrite that as x cubed plus 4 cubed. So I'm going to use x and 4 on everything right here. I got same, opposite, always positive. And this is the first one. This is the second one. This is the first one squared. Multiply them. Second one squared would be 16. And all right, so got the soap out of the way. On the bottom, I don't think this is going to work. Dadgummit. Let's factor it. X, 2 numbers to add to give me 2. Multiply, give me -8. This would be plus 4 minus 2. So I like that these will zap, but I don't like that I'm left with x minus 2 because that still gives me 0. Man, I don't like this. All right, so pew, pew, plug in 2, you get 0. Who made this problem? What an idiot. I hope I made it. Sorry if you made it. All right. That thing's not going to exist. That's disappointing. We're going to have an asymptote at 2. You could graph that thing on Desmos if you really wanted to, and you're super bored. So let's write does not exist. We did some algebra. We simplified it. We still plugged it in, and it still gave us 0. Does not exist. All right, let's look over here. You can try that one. Spoiler alert, answer's 3. There you go. Yes, this looks disgusting. Like when I first saw this problem, I was thinking I could factor by grouping. I don't know if your Algebra 1 teacher, Algebra 2 teacher taught you how to factor by grouping, like right here, take out an x squared, maybe right here, take out a 5. That didn't really work for me. Well, I'm not gonna say it didn't work for me. It didn't work as nicely as I wanted it to all the way around. So what I want to do is I want to synthetically divide up top. Okay, so I'm gonna guess we've synthetically divided, factors of 10 over factors of 1, factors of 10 over factors of 1. I'm gonna try 2 for the top one. So let's take the top one and synthetically divide. That would be 1, -2, 5, and -10. And we're gonna see if 2 is a factor of the top. Okay. See, my goal is I want to get the x minus 2, like in the back of my mind is I'm hoping that x minus 2 is going to be a factor because when I plug that in, that gives me 0. And that would be a problem in the denominator. Okay. So that's why I'm trying 2 first to see if it's going to work. I hope it works. We'll see. I should have edited this, but whatever. Bring that down. You get 2. That'd be 0, 0, 5, 10. Sweet. Who needs editing? That's stupid. All right, so that means that what? X minus 2 is a factor, and that would leave me with what? So if this was cubed, this would be x squared plus 0x plus 5. Sweet. All right, so up top, we've got now the limit as x approaches 2. Up top, we can write it as x minus 2 x squared plus 5. All right. Please, dear Lord, let x minus 2 work on the bottom. Editing is stupid. All right, let's take 2 down here so that hopefully we can zap this thing. Whoever made this problem, please have made it nicely for all of us. We want it to work out nicely. This would be 1, this would be 2, this would be 4, 8, -5, -10, boom. All right, so that would mean x minus 2 is a factor of that polynomial. This would be x squared plus 4x minus 5. I even think that thing factors right there, but I don't know that we'll need it. That would be x minus 2 times x squared plus 4x minus 5. Pew, pew. All right, so now if I take that 2 and plug it in down here, that would be 4 plus 8. So we're not going to get 0 in the denominator. Sweet. Thank you, whoever made this problem. So plugging in 2, direct substitution here. 2 squared plus 4 times 2 minus 5. That would be what? 4 plus 9 over 4 plus 8 is 12 minus 5. That's not right. I don't know. I don't like that. Why is that so ugly? 4, yeah, I guess we'll say it's 9 over 7. I hope that's right. I wrote equals to. What an idiot. It's equal to 9 over 7, if you're wondering. If you want to write it again, there you go. It's equal to 9 over 7. Man, I was really hoping for a nice answer there.